All right, hello everyone. So we're going to go over our first wave notes. So you can take as many notes as you need. You don't necessarily have to get every single thing down. I've kind of let you know when you should start writing things down. But if something looks unfamiliar, you don't recognize it from the vocab or from the BrainPod video, then maybe that's something you want to write down. Okay. So what we're going to go over are wave properties, which are basically how do waves behave? What are the different parts of the wave? So we're going to go over the wave characteristics. Okay, so what is a wave? When we talk about a wave is just something that disturbs a medium. When we hear the word medium, so when you hear this word medium, you should think of a material. So medium is just another word for material. Okay, so for example, if I have ocean wave, the material would be water. If I have a sound wave, it's traveling through air particles, the medium would be air. So most waves need a medium, not all waves. Okay, mechanical waves are waves that require a medium, whereas electromagnetic waves can travel in empty space, such as light. Light doesn't need a medium to travel through, but there are certain waves like sound that do need a medium to travel. Okay, all right, so let's go ahead and go on to the next slide. So when we're talking about waves, the simplest wave we have is a single pulse. So if we have one disturbance, that would be a pulse. Okay, for example, if I have a piece of string, I move it once, it ends up creating a pulse. If I have the same disturbance repeating over and over and over, then I end up getting something that looks like this, a periodic wave. So that's what we're going to be studying. We're going to be studying waves that have the same disturbance. Okay, let's go ahead and break this down. So if I look at this, this is a wave. This is just a couple of vocab words you need to know. So the top of the wave are what I call my crest. So this would be the crest. Okay, this would be crest. This would be a crest. It's the highest points. Lowest points would be the troughs down here. Okay. All right. Then I have, so moving on to the next part, we have our wavelength. So the wavelength is going to be the distance from, this can vary, but it's the distance from one crest to another crest. That's one wavelength. However, it doesn't have to be that. It can be anywhere where the wave is doing the exact same thing. So for example, here's the bottom of the wave. Here's the bottom of the wave. That's one wavelength. We represent wavelength with this Greek symbol, lambda. It's basically like an upside down y. So this would be one wavelength, which we would represent like that. Okay. All right. Let's look at another example. So this would also be one wavelength here. Here, the wave, if you notice, the wave is going up, right? So the wave is going up here. The wave is going down here. So we have to find where it's doing the same thing. So here, the wave is also going up. So from here to here, that would be also one. That would be one wavelength. Okay. So a full wave goes up, and then it goes down. That's one wave. Okay, just keep that in mind. Okay, let's go ahead and move on to the next part. So next we have, after wavelength, we're going to have frequency. So frequency is the number of waves that cross a certain point per second. In other words, it's waves per second. So pulses that cross per second. So for example, let's say I have a wall here. Okay. If I have if these waves are hitting this wall and I have a few waves hitting every second, then that's a low frequency. I don't have many waves per second. But in this example here, if these waves are traveling at the same speed as these waves, I'm going to have a lot of waves hitting this wall back and forth. So this would be high frequency. I have many waves per second. Okay, so high frequency equals many waves per second. Low frequency equals few waves per second. Okay, let's erase this. Then we have period. Period is just the time it takes for one pulse, in other words, one full wave, to make it through a certain point. So, for example, let's say I have a wave here. So I have a wah and I have a wave. The time it takes for this wave to cross this wah, that's the period. For example, so if it takes 3 seconds to cross, if it takes 3 seconds to cross the line, then that's my period. My period is 3 seconds. Okay, so you could also think about it this way. Period is, let's say you're on the boat here. The time it takes for the boat to go down the wave and then back up, that's your period. So if it takes you 5 seconds to go down and back up, then your period is 5 seconds. Okay, it's just the length of one wave. How long, not the length, but rather the time it takes one wave to pass a certain point. Okay, so then we have after period, that's pretty much it. This is just a summary. So we have the crest, we have the trough. Did we talk about, actually, I think I skipped this one, which is the amplitude. Okay, so the amplitude is going to be how much is that medium disturbed. So in other words, if I have a rope, the rope, for example, that is attached to a wall. So if I have a rope that's attached to a wall, actually, let me redraw that. If I have a rope here that's attached to a wall, if I pull that rope a small amount, if I do a small disturbance, then I'm going to have a small wave, right? Which means I have a small amplitude. So amplitude is just a measure of how much is disturbed. If I take the same rope and I pull it up and down really, really hard, then I'm going to have a way bigger amplitude, right? So amplitude is just the distance from the midline to the top, or the midline to the trough. Either way, this or this, that's always going to be equal to amplitude. Okay. All right. So how does, you also need to understand how amplitude relates to intensity. So in terms of light, things that are very dim have a low amplitude. So for example, if you have a red light that's not that bright, it would look like this. If you have a red light, I'm just picking red as an example. If you have red light that's very bright red, it would look like this. So the more brighter it is, the bigger the amplitude. Okay. Same thing with sound. Something that's very loud would look like, so if something's loud, it's going to look like this. Very big amplitude because you're disturbing the air a lot. Okay. Something that's not that loud, so something that's kind of quiet, would have a very small amplitude. It wouldn't really disturb the medium that much. Okay. All right. Let's just go into the summary here. So the summary which we have here is just the crest, trough, the amplitude, and then last of all, the wavelength. Okay, so the last thing you have to be able to do is you have to be able to count how many waves we have in a certain system. So let's go ahead and do that now. So let's say I have a wave here. Okay, so this wave goes up, down, then up. Okay, you're going to be asked to count how many waves are in this. So, well, here the wave is going up, here the wave is going down, here it's going up. So from here to here, we would have one wavelength. Okay, here it's going up, right? Here it's going down, here it's going up. That's another wavelength, because remember, all waves go up and then down. So that would be one wavelength. So in total, we have two wavelengths. Remember, wavelength we represent with that Greek letter lambda. Okay, let's do another example. Say I have something like this. Let's keep this one simple, just like that. How many waves do I have? Well, I'm going down, but I don't go back up, because a regular wave should go back up as well, right? But that doesn't happen. So this isn't a full wave, it only goes down. So this would be half a wavelength. Okay, let's look at a little bit more complicated example. So let's say we have a wave here. We have a, let's scroll down here. We have a wave, so that's fine. Okay, this wave is going here and then here. All right, this is not perfect. We just assume that they're all the same size. So here, the wave is going down. So that's the start of the wave. It's going down. Here, it's going up. Here, it's going down. So up and down, that'd be one wavelength, right? On this side, it goes down, but it doesn't go up again. So that's not a full wavelength. That would be half of a. That would be half of a wavelength. So that would only be half of a wavelength. So in total, we have 1.5 wavelengths there. Okay, and that's all you're doing. So just remember that every time a full wave has to go down and it has to go up. Okay, and we have to always count from the starting point. So if you have a wave such as this, it looks like this, you can't just say 1 wavelength, 2 wavelengths. You can't do that. You have to start from the beginning, which is here. Look at what the wave is doing going up, and then you have to go all the way and count all the way. So you can't just go from high point to high point. You have to start from the beginning, and that's your first wave. Okay, so for this assignment, you're gonna have to go to the class site. When you go to the class site, you should already be there, but you'll see the assignment in week 10, lesson 3. So the assignment's going to be here. Make sure you upload this to Schoology. You can write your answers on a separate sheet of paper, or if you want, you can also print this if you have a printer, but you don't have to print it. But if you print it, it might make it a little bit easier for you. And then take a picture of this once you're done, and you just upload it to Schoology. Okay, if you have questions, just kind of email me, but I can labeling. So you just label different parts of the wave. That's on the notes. Here we're counting wavelengths, which is what we just did. Okay, in this part, you have to refer to frequency. So if someone has a high pitched voice, they would have a high frequency. Okay, so just keep that in mind. So if they have so for example, the kid says that the dad has a deep voice, so that means he would have a low frequency. So low frequency equals low pitch, high frequency equals high pitch. Okay, here you just figure out which one has the lowest amplitude, and then you compare it to different parts of a song. Okay, remembering that if something's quiet, that means it has a low amplitude. So you have to label which one of these waves represent the quiet part and which waves represent the loud part. Then last of all, what you're doing in this last part is you're comparing these waves to the standard wave. Okay, and all you got to do is put high, low, or same. So for example, here in this example, I want to say, is my amplitude bigger or smaller? Well, this amplitude is kind of small, this amplitude is bigger. So I would say higher. Frequency. If we assume that all of these happen in 1 second, well, that means I have in 1 second, I would have about 1 full wave passing. This is also 1 full wave. So the frequency would be the same. Okay, so that's what you're doing. And then you would go again and you compare part B to this. Does this have a higher amplitude or lower amplitude? Does this have a higher frequency or does this have a higher frequency? Then you compare C to this, then you compare D to this. So everything's being compared to the standard wave. Okay, if you have questions, email me. Just make sure you guys get this in before the due date.